Hello, everyone. My name is Hao Liu. I'm from the Hong Kong University of Science and Technology. So today I will present a topic on the graph neural network approach to conceptual cost estimation. So I will first introduce the problem and then present our proposed method, and followed by the results and discussion, and finally have a conclusion and future work. So the conceptual cost estimation is to predict the construction cost at the early stages of the project. So with the current estimation, we can have the reasonable project budget, and we can also plan the proper cost control action ahead. However, as we know, the early stages have very limited information and high level of uncertainty, which means we need to rely on the cost engineer's experience and judgments. But these subjective judgments may be unreliable, and it's also a labor-consuming process. So the problem here is how to do the cost estimation accurately and efficiently. And for this problem, existing studies have adopted the machine learning models with flat tabular cost factor inputs, like the design information, the project characteristics, and the economic indicators. And they've made some improvements on the currency efficiency, but according to existing studies on the cost factors, there are impaired relationships among different cost factors, and which are not considered currently. So there is a lack of consideration on these inherent interrelationships among the cost factors, which is unrealistic and unreliable. So here the problem is how can we consider this interrelated modeling for the cost prediction, which means we need to first find a proper representation of these interrelated cost factors, and then have a prediction based on it. And for this problem, the hypergraph deep learning is a promising technique. So a hypergraph is a graph representation. We can have a hyperedge to join any number of nodes to represent different relationships. And based on it, we can develop the hypergraph neural network to extract and propagate the features within the hypergraph. And so it provides insights on the representation of the interrelated cost factors and also the prediction with it. With that being said, we aim to develop a hypergraph deep learning based approach to have a concurrent and efficient conceptual cost estimation. So we will first formulate a hypergraph to incorporate the cost factors and the interrelationships. And then we will develop a hypergraph neural network based on it to have an end-to-end cost estimation. And this is an overview of the proposal method. So there are two parts. The first part is the identification of the cost factors and also their interrelationships. So we first identify these factors and also their relationships, and then formulate the hypergraph representation. And based on it, we develop the hypergraph deep learning model to do the training and testing to finally output the construction cost. And so I will introduce the details in the following slides. And so for the first part, we first identify the cost factors and also their groups, and also their correlations through the literatures and the industry professionals. And this is an identified hierarchy of the construction cost factors. So in general, it can be influenced by three major aspects. And each aspect can have certain specific factors, like design information can include the construction floor area, the building height, and soil condition, etc. And besides this vertical hierarchy, there are also impaired relationships in the same layer horizontally, like the project characteristics and the economic indicators may have mutual impact on the design information. And for the specific factors, for example, the project type can have an impact on the contract type. And based on this, we formulate these cost factors and the interrelationships in this hypergraph. So there are unidirectional edges to represent the certain effects from one monodes to the other, like the contract type and the location may have mutual impact on the duration. And there are also bidirectional edges to represent fuzzy interactions, like the interaction between the different economic indicators. And then, so here we can see our hypergraph has the characteristics of the hierarchical structure by these two levels of nodes, and also the interrelationships among multiple nodes through the hyperedges. And this provides the insight on the design of our hypergraph deep learning model. So correspondingly, we developed this hypergraph deep learning model. And so we first have a two-level architecture and a graph readout operation to deal with the hierarchical learning. So in the first level, we have three branches corresponding to three sub-hypergraphs. And then after the graph readout operation, we produce representative inputs for the three higher level nodes. And then at the second level, we have another branch to take these three higher level nodes as inputs to output the construction cost. And inside each branch, we integrate the hypergraph convolution layers to have the hyper-edge learning for the consideration of this interaction between multiple nodes through the hyper-edges. And for illustration, we use a dataset in Hong Kong, which covers different kinds of schools. And for evaluation, we adopted the mean episode percentage error, which means the percentage deviation of the predicted cost from the actual cost. So here, the lower value means that we have better model performance. And this is the model prediction results. So we compare our model with other common methods in existing studies. And here we can see the proposed method is better than Nassau and SVR. This means we are better than traditional statistical and machine learning models. And it's also better than the common deep learning model with the tabular input form. So this means considering the interrelationships among different cost factors in the machine learning model is important. And it's also more account than the traditional graph deep learning model like the GCN with the common graph input form. So this validates the importance of considering the higher order interrelationships through the hyper-edges in the hypergraph in our previous formulation. And so in short, to address the gap on the lack of interrelated modeling for the construction cost prediction, we first propose a hypergraph formulation to represent the hierarchy and their and the interrelationships among these cost factors systematically. And then we develop a hypergraph deep learning model to integrate different mechanisms for the hierarchical hypergraph learning to have the end-to-end cost prediction. And finally, the result shows that it can achieve better cost prediction accuracy than the traditional machine learning models. However, there are also some limitations. For example, the method is a black box nature, but the explainability is important for decision making in construction projects. So in the future, we may explore the explainable AI techniques to increase the explainability in our method. And also this study is limited to certain project scope, which is a school project. So in the future, we will apply the method to more types of projects for broader applicability. Yeah, so these are the references, and that's the end of this presentation. Thank you.